What's up, math fans? Today we're going to be solving radical equations. That's basically an equation with a radical in it and a variable also. We got to find something to solve for. So how do we do that? Hopefully you're already comfortable with radicals, and hopefully you are familiar with my other video, which was rational exponents. So you understand this fact right here. These are just some facts well, this one is a fact. These are examples I'm going to get to in a second. So I already explained to you that the square root of x can be rewritten as x to the 1/2 power, and I said that the little index here, which is a 2, and you usually won't see that 2 if it's just the square root. The 2 is implied, but I snuck it in there. The index can be rewritten as the denominator over here. So the numerator is basically the power that is being raised to, or the exponent, and then the denominator is the index. Alright, so this is a fact that you already know. Now, let's say you're doing something like the Pythagorean theorem, and you do all this work and you come out to x squared equals 36, and you have to isolate x, so you're not done. You have to do one more step, and that step is the square root. And you learn that the square and the square root are inverses, so they cancel each other out. And x is now alone. Whatever was inside that radicand drops down. And the square root of 36 is 6. Okay, so I'm done. Actually, people can argue that here x equals positive or negative 6, but because I'm using a real life experience Pythagorean theorem, I'm talking about lengths of a triangle, I'm just taking the positive square root. So the positive square root of 36 is 6. If you understood that, then you should understand why you're allowed to do that. A square and a square root, they're inverses of each other, and here's why. I'm going to rewrite that. So x, where did I start from? X squared equals 36. Instead of taking the square root, what I'm going to do is raise it to an even higher power. So I'm going to take both sides. Of course, whatever you do to one side, you have to do the other side. So I'm going to take both sides and raise them both to the 1/2 power. To the 1/2 power, to the 1/2 power. Okay? So here, hopefully you can see that. What do you do when you raise a power to a higher power? You actually multiply the powers. So 2 times 1/2, those are actually inverses or reciprocals of each other. 2 times 1/2 is 1. Half of 2 is 1. So this kind of cancels itself out, and x drops down, and 36 to the 1/2, you have to know, really means same as this, the square root of 36, which is still 6. So why would I do it that long, complicated way if I could just do it this way? It doesn't matter which way you do it, it's just whichever way is easier. And in the future, when the problems get more complicated, you'll see sometimes this way is easier, sometimes this way is easier. It's really up to you. I just want you to see both. For example, let's look here. X to the 3/2 power equals 8, solve for x. So I could say, well, I know that x to the 3/2 power really means x is the radicand. There's a radical symbol. The 3 is the exponent, and the 2 is the index. Okay? Exponent, index, exponent, index, exponent, index, numerator, denominator, equals 8. But did that really help it, or did it make it more complicated? To me, it made it more complicated. I should have never done that. All I had to do was raise both sides to the inverse, or the reciprocal, of the given power. If the given power is 3/2, I flip it and raise it to the 2/3 power. Whatever I do to one side, other side. 2/3. So the 2 cancels with the 2, the 3 cancels with the 3, and x drops down. Okay, so as you can see, this step was irrelevant. True, but irrelevant. Now 8 to the 2/3, what does that mean? Now it might help to know what it means. So 8 to the 2/3, what did we say? That's 8 radical. The index is 2, but the index is 3 now, right? The bottom number is the 3, the index is 3, and the exponent is 2. Now it does help, because now I need the cube root of 8, and then I'll square it. The cube root of 8 is 2, and 2 squared is 4. So my final answer is x equals 4. X equals 4, okay? So sometimes it does help to do it with the exponent way. Sometimes it's just easier to do it with the radicals. Whatever works for you. Let's do a few practice ones. Do them on your own. Pause it, and then let me do it for you. Match your answers, all right? Radical, x equals 5. I want to get rid of that radical, so I'm going to raise both sides to the second power. That's pretty easy. Second power and radical cancels each other out. x equals 25. Done. Some of them are really quick. Now, what happens here? I should just square everything, right? No, you're not allowed to square individual terms. If anything, if you wanted to make this complicated, you take the entire left side and square it, and the entire right side and square it, and you would eventually get to an answer. However, if I'm squaring this, that means I have to write this twice, and then I have to do FOIL. And that's a lot of work that can be avoided if you isolate the variable. Isolate the variable. We've been doing that for years, still do it here. Isolate the variable. What does that mean? It means don't square both sides until you isolate the variable. So let me just subtract 3. That's the additive inverse. We've been doing that for years. 3's cancel out. 8 minus 3 is 5. Radical x equals drops down. And oh, look at that. Same question. Square both sides now. And x equals 25. Okay? So it was the same question in disguise. Isolate the variable. Get rid of that 3. Bring it over here. Now, what was the difference between 2 and 3? Look at this. Look at this. Here the 3 is inside the radical. So can I subtract 3? No. Now the radical is already isolated. I'm ready to square both sides. So now when I square both sides, I don't have to do FOIL because this immediately cancels with that. X plus 3 drops down equals, this time 8 squared is 64. Oh, that's a one-step equation. Now I can subtract 3 on both sides and x equals 61. So please understand the difference between these two questions. Let's go. Next one. Is the variable isolated? No. There's a coefficient outside the radical. Let me get rid of it. So this is what? 10 equals radical 25v. Now the radical is isolated, so I can square both sides because a square and a square root cancel out. Notice all of these I'm squaring both sides because they're all square roots. I only did one. That was a multi-step one. So I'm making it easy for you. But the same thing holds true if this was a cube root, you would cube both sides. If it was fourth root, you would 4 both sides. Raised to the 4th power. Just doing the inverse. So what happens here? 100 equals 25v. And now it's very easy, one-step equation. I divide by 25 on both sides. And if you can see this, v equals 100 divided by 25 is 4. Okay? Also, what I'm skipping is the check. You should always check because these not always work out to an answer. Sometimes you get an answer, you plug it in, and it doesn't work. So here if I plug in 25, it'll work. Here if I plug in 25, I get square root of 25, which is 5. 5 plus 3 is 8, so that works. Here, 61 plus 3 is 64. Square root of 64 is 8, so that works. Here, plug in 4, see if it works. I believe it does. And one more. This is the 1/2 power. I can rewrite it as a radical. I can rewrite this one as a radical. Radical on both sides. What do? I'm not scared. I take the whole thing and square it. Take the whole thing and square it. Just like I've been doing. Square both sides. Here, the square and the square root cancel each other out. The square and the square root cancel each other out. Notice 1/2 power really means just the square root. So I'm doing the same thing I've been doing, just it looks a little different. So the radicand, whatever's inside, drops down. And the x over 5 drops down. No more powers, this is really easy. Oh no, a denominator, I'm so scared. Put this side over 1 and cross multiply. Or you might have learned, just get rid of the 5. This means divided by 5, so the inverse is to multiply by 5. So I have to multiply by 5 on the right and the left side of the equation. Here it's easy, 5's cancel and x is alone here. Here I actually have to distribute the 5. 5 times 72 I think is 360, and 5 times x is 5x. So x is still not alone. Now you just have to have algebra skills. I'm going to add 5x to both sides. And if you can't see, I'm going to come over here. 6x, right? X plus 5x, 1 potato plus 5 potatoes is 6x, equals 360 drops down because the 5x is canceled out. And then I divide by 6, and x equals 60. Again, take the 60, go all the way back to the beginning, plug it in here, make sure it works. If I said anything too fast, you're allowed to pause it, you're allowed to rewind it. Guess what? I'll say it again. You're welcome. See ya.